Okay, here we go. Last thing, right? Last topic in Calculus Math 31, volumes of revolution. So what we want to think about is describing a solid shape that would result if you take this area, so on a flat plane, and you rotate it up in space about the x-axis, right? So it's going to go into the board and around and then come up out of the board and rotate through. And so this will give us a what? Cone. And this will give us a, well, or I tend to think it was like a Hershey's Kiss or something. Okay, what's this going to give us? A sphere. And then that thing, it's called a frustum or a frustum.
Damn it, I was about to say that.
Yeah, it's like a truncated cone like they have the lions sit on in the circus, right?
Of course.
Because you wouldn't want a lion to sit on a cone, they'd probably get angry. And then...
A router thing.
Yeah, and what will this give us?
A cone. Sorry, not a cone. Like a circle for a cylinder.
Yeah, a cylinder, right? Small, not very high cylinder, I think. And so then, if we go here, here's some animation. So replay the animation. Oh, look, so there we go. So that's what we're talking about, right? And there's your frustum. Right?
It's a GIF.
It's a GIF.
GIF. I like GIF. GIF sounds.
I'm sorry, pronounce graphic.
If we do it in a hurry, we can do it in a jiffy.
Oh.
Okay, so there's the idea, right? That you're rotating this through space, or here's another version. And this is actually kind of nice because you see a wireframe, so you can sort of see. And then it's going to fill it, it's going to skin it.
How many ways are creating that?
Yeah, I don't know. It's not a cat, so I don't know how many ways we can skin it.
Why do you know how many ways? I think we do.
Well, we don't, but we know there's more than one way.
Is that supposed to make a hole?
And that actually, that's a rotation, but around the y-axis, which
How is this fit?
can be done, but we don't do.
Right, we don't.
Okay, so look, it's Gabriel's horn or Torricelli's trumpet. I don't know who. And then here's just another, right? So there's just some other areas being rotated around. Okay, so we got the idea. So those shapes are called volumes of revolution. It's possible to determine the actual volume of the shape if the functions that bound the area is known. I meant to change that to an R, but I didn't. So let's look more closely at the area in the middle of the bottom row. So what we do is we have a narrow rectangle, right? Like the ith rectangle. The ith. And, no, here it is. The ith rectangle. What is the height of said rectangle? So we call that f of x sub I, right? So the function is the function f of x, and then the ith rectangle has this height. And what is the width of the rectangle? Oops. Width we've generally referred to as delta x, right? So if we imagine rotating this around, or we just go back to the previous ones where we were rotating this around, but you took that rectangle and rotated around, then what shape would you get? Cylinder, right? So we're going to call it, you generally call it a disc, just because it's kind of a thin cylinder, or a cylinder, right? So a cylinder. They're called discs, right? But they are cylinders. They're just thin cylinders.
What is this, the 20th century?
What's the radius of said cylinder? Yeah, so f of x sub I. And what's its height? No, it's just delta x, right? So it's the width, right? It's probably because it's a disc, right? It's like a quarter. Think of it as like a quarter, a dime, or something like that, right? I mean, a dime is a cylinder. You just don't think of it as a cylinder so much because it doesn't have a lot of height. And that's what we're doing, right? We're taking things that don't have a lot of height. Actually, the infinitely small heights. But so what's the volume of a cylinder? So the volume of that disc or cylinder. Never know whether to spell disc with a K or a C.
If you spell it with a C, you can run the words into each other, disc and cylinder.
Okay.
Yeah, it looks cooler. C or a K?
Looks like a robot.
Okay, so the volume of that cylinder can be found using the formula. What's the formula for volume of a cylinder? Pi r squared h, right? Which becomes, okay, so we've got pi, we got r, and we're going to square that. So r is f of x sub I, right, squared, and h is delta x. So the volume of the cylinder. Okay? Now, if we imagine infinitely many adjacent disks of infinitely narrow heights, creating the volume of the shape produced by rotating the area under F, and we add up the volume of all those disks, then we will get the volume of that solid, right? So the volume of revolution. So V is equal to the limit, as n approaches infinity, of the sum of I equals 1 to n of pi r squared and then h. Okay, and we're just going to add up all of those infinitely thin disks. Now we can do that, right, using the integral from a to b, right, over some interval of pi f of x squared dx. Okay, and that formula is given to you on your formula sheet. Although I think the pi, because it's a constant, is stuck out front.
So what happens to the delta?
Yeah. What's that?
Right there. Right.
What happens to the
Here we
alpha?
write it as a delta x, here it becomes a dx.
What happened to the alpha part? How? Yeah.
What happened to the what?
Get it? Because it's
No.
delta x, but you still have the d and the x, so the alpha disappears.
Oh, the alpha. Yeah.
No, my hand.
Anyway.
What about the x bar?
Becomes f of x.
Dated, like physical abuse.
Okay.
Wait.
So,
Alright.
so I stole this little diagram here, and so if we're going to do the volume of the solid produced by revolving the area between y equals 2x and the x-axis, so here's y equals 2x, and here's the x-axis, and here is our disk, right, or one of our disks, and we're going to go from 0 to 3. Okay. Then what we do is we start with the formula, which is on the bottom of your formula sheet, and looks like this. So V is equal to pi. Okay, now what does it actually look like? Integral, so they're giving an indefinite. F of x quantity squared dx. Okay, and so we can just fill that in, right, with what we want. So V is equal to pi, definite integral, going from 0 to 3, so we want x 0 to 3, of f of x. Okay, what's f of x? Okay, that's 2x. Okay, quantity squared dx. Okay, so 2x quantity squared is 4x squared. So V is pi 0 to 3, 4x squared dx. So that's pi. And what's the integral of 4x squared? 4 over 3x cubed, yeah, so 4/3 x cubed evaluated from 0 to 3. Okay, so 4/3 is constant, we can pull that out. So we could say it's 4/3 pi, and then we've got x cubed, so 3 cubed minus 0 cubed, and 3 cubed is 27. But 3 goes into 27 9 times, giving us a 4 times a 9, or 36 pi. Do you want more detail, or is just 36 pi good enough? So 36 pi. And it's a volume, so it's cubic units or units cubed, yeah.
On our formula sheet, it shows it without a definite integral, but on here you can only, like, you get it by having a definite
Yes.
integral. Can you put it in with an indefinite?
you could work out some general formula, and then if you wanted to do a specific.
Okay.
Yeah. So you can work out, here's a general formula for volume now if I want to do a specific. Generally, we're going to ask for specific volumes, right?
Okay.
Units cubed, or 36 pi cubic units. Determine the volume of the solid produced by revolving the area under y equals sine x 1 revolution about the x-axis from x equals pi over 2 to x equals 5 pi over 6. Okay. So if you like, you could draw, a little diagram with sine x and there's pi over 2 and there's 5. So this would be the area that we're going to rotate. Okay. We don't need the diagram, right? Okay. So we got a formula, right, which just says v is equal to pi, definite integral, so pi over 2 to 5 pi over 6 of sine of x quantity squared dx. Okay, so all we need is the integral of sine squared x. So I'll pause, give you a moment. You can work out the integral. Okay, so we have pi times, then we've got the integral. So 2x minus sine 2x over 4. And that's from 5 pi over 6 to pi over 2. So now we substitute in, well, actually we could pull the 4 out, right? Let's do that. So one reason putting the 4 as a common denominator is that you can, pull that out here. And that makes this a little bit easier. Not prettier apparently, but easier. Okay, so pi over 4, big square bracket. And so we're going to get 2 times 5 pi over 6, so 2 times 5 pi over 6 minus the sine of 2 times 5 pi over 6. And let's enclose those in parentheses, minus, right, because you have to work that out separately, right? We're going to do the first with the 5 pi over 6, minus, and then the same deal with the pi over 2 minus the sine of 2 times pi over 2. Okay, and then all of that is times pi over 4. Okay, so 2 goes into 6 3 times, so we get 5 pi over 3 minus the sine of 5 pi over 3. And we can distribute the minus through, so this will be minus pi, and then this will be plus the sine of pi. All right, and then all we have to do is evaluate. Well, okay, sine of pi is just 0, right? 0. So all we have to do is get a common denominator for the 5 pi over 3 and the pi, and get the sine of 5 pi over 3. So sine of 5 pi over 3 is the same as the sine of pi over 3, which is root 3 over 2. And it's positive, right? Quadrant 2. Okay, so what do we got? 5 pi, and then this is 3 pi, so it'll be 2 pi over 3 minus root 3 over 2.
Should be plus root 3 over 2. Yeah,
Oh, no.
Yeah.
Wait.
Because it's negative, but you're taking, like, you're subtracting a negative.
Oh,
which
5,
means
it's
positive.
quadrant 4, isn't it? 5
Yeah.
pi over
Yes.
3. Yes. Correct. Yeah, I don't know. Why did I say? We should use tau. I was thinking,
We should average the two and get tau.
Well, if we average the two, then we're just at 3/4 pi. Oh no, pi, 2 pi. We're at 3/2, 1.5 pi. No, tau is nicer because tau is 2 pi, right? So that if you have the unit circle in terms of tau, halfway around the unit circle is half of tau, instead of halfway around the circle is pi. Right? So and a quarter of the way around the unit circle would be a quarter of tau, right? Because tau is just 1 tau. Tau is
halfway around the circle is 2
How did they come up with that system of measurement?
there's the Tau Manifesto. Seriously.
Is that like the
I'm
communist?
not here to learn, I'm here to make dumb math.
I don't know. I'm now going to Google the Tau Manifesto. Tau Man. Here we go. The Tau Manifesto. Tau Day. No, really. Pi is wrong. Last chance to get your official Tau shirt, people. Which, and Tau Day is coming up, right? Because it's June 28th, right? It's 6.28. So anyways, there's official Tau shirt, the Tau tie. Short version, long version.
If tau is double pi, why does it only get half the symbol?
Pi is still wrong. I don't know. Yeah, it's interesting. Right? It looks like it's a half of a pi.
But it's actually twice.
But it's actually twice a pi. Yeah. Okay, and then what can we do with this? We can multiply this through, giving us what? 2 and then 4. So the 2 pi squared over 6 plus root 3 over 8. And we could go with a 24 if we wanted. And what would that give us? 4 pi squared?
Don't you need root 3 pi over 8?
Yeah, we do, don't we? Root 3 pi. Or 3 root 3 pi. So just be aware, especially in multiple choice, be aware of different possible versions of your answer, right? Like you get this, but this is what's shown, right? Or this is what's shown. So one thing in multiple choice is to kind of at least glance at the answer to say what form is this answer in, so that when I'm working it out, I can push my answer into that particular form, right? Does it have one denominator, or is it just an expression? It might even be just left like this, right? Pi over 4 times this. Okay, so they're all possible. And then cubic units, right? I guess. Put that on. Cubic units. Or units cubed. Units cubed. Determine the volume of the solid produced by revolving the area enclosed by y equals 4 times the square root of x and y equals 2x. Okay, so we're going to have to kind of draw this out. Well, let's do that over here. So y equals 2x goes like that. Now 4 times the square root of x is going to be the square root of x stretched by. So where are they going to meet? Or do they meet? Yeah, so they must meet, right? Because they didn't say between. Okay. So if this went like this, right? If you had a volume like this, then we would say, well, we want it between here and here, right? So it's like they don't cross. So here they must. So let's start with seeing where they cross. So 4 root x equals 2x. Okay, so solve that. And so what do you do? Square both sides? Minus 4. Okay, so they're going to meet at 0 and 4. Okay, so let's sketch this out. So there's y equals 2x. And what are the values at 1? So 4 root x at 1 is going to be 4. Right? And 2, this will be a 2. So 4 root x is going to be above. Right, so there's 4 root x. And that's 4, and that's 0. Now it's handy to know who's above who, because what are we going to do? We're going to figure out the volume of 4 root x, and then we're going to subtract from that the volume of the 2x, right? So we need to know who's got the upper hand here, right? Like which is the upper function. But I suppose you could just do an absolute value. So the volume we want is the volume of the, so let's say it's the volume of the 4 root x minus the volume of the 2x. And we're going from 0 to 4, so it's pi, definite integral 0 to 4 of 4 root x quantity squared dx minus pi integral from 0 to 4 of 2x quantity squared dx. So we can combine that, right? We have the difference. If you have the difference of integrals, you can just do the integral of the difference, right? And it's over the same. So pi 0 to 4. Okay, so what's 4 root x squared? Okay, well, we did that. 16x, right? So 16x minus, and 2x quantity squared, we did that, is 4x squared dx. Okay, now, so you could, if you like, you could just work this out separately and then work this out separately, right? And then do the subtraction, or you can combine them. So the difference of the integrals is the integral of the differences. And now we just need the integral, so pi, and what do we get?
8x squared minus 4 over 3x cubed.
Yeah, so 16x squared over 2, so 8x squared minus 4/3 x cubed from 0 to 4. Okay, so we just plug in. And the 0 is just going to give us a 0, right? So both of these terms have x's. Pi, so 8 times 4 squared minus 4/3 times 4 cubed minus 0. I'm going to throw that in just to say, look, I really did, do this. And I guess we could do a little more detail. Okay, 0 minus 0.
0 squared minus 0.
Well, 8 times 0 squared minus 4/3 times 0 cubed.
But that looks like 8. So.
It's a face.
Is it happy or sad?
It's, well,
Okay, so 4 squared is 16 times 8 is 80 and 112? Yeah. 80 and 32? No, wait.
Just
8.
put them both in so that
No, it's 848. It's 128.
holy
128.
fuck, how is this fair? I was a pimp and a philosopher once, and
You can
coward nerds doubted me.
you can do long multiplication if you like. I know that's a skill that is lost in the. 4 cubed is 64 times 4 is 256. So 256 thirds. So we got to multiply 128 times 3. So that one I really do need to go over here. No, 256 is a power of 2. So.
If you change it from 8 times 4 squared to just 2 times 64, then you get 2 times 64 minus 4/3 times 64, which is just 2/3 of 64. You need to do all this extra work.
Okay.
Alternate option, Barrett. How about you fight me?
I didn't get. Okay, wait a sec. What? Hang on. Let me just do that. Let me finish the long way while I'm at it. So 4 carry the 2, 6, 8. So 384. So 384 minus 256 over 3. All right, we're getting the same number that you did.
It's 120.
7, 14, 8, 2, 128.
Wasted effort.
Units cubed.
Yes.
Okay, you get the same number? Whatever, as long as you get 128 over 3, pi units cubed or cubic units?
Yes, I
then?
did.
Did you? Excellent. So how'd you do it?
I turned it 8 times 16 to 2 times 64. And
Okay.
then I just had 2 times 64 minus 4/3 and 64.
Oh, right, because the 256 is also a power of 64. Okay. Anyways, however you like to do your arithmetic, you may do it and get 128 over 3 cubic units.
Everybody be careful.
Okay, in the interest of full disclosure, this is a redo because I kind of messed this up a bit the first time. So here we go. So let's sketch this out, and you notice we have an area from 0 that we're going 0 to 2 on the x values because these two guys don't intersect like the last one. So y equals the root of x minus 1 is the square root of x, but shifted 1 unit to the right. So that'll look something like this. And this will be 1, and there's 0. And then 2 to the x, just your basic exponential function, is going to do this. And so we'll call this 2. And there's 0. So from 0 to 2. So it's this area here, which will be rotated. So then what I'm going to have to do is take the volume. So this was y equals 2 to the x. Take the volume of 2 to the x from 0 to 2, and from that subtract this volume. That, let's hear, maybe we could change color. From that subtract this red volume here, which is under the square root of x minus 1 from 1 to 2. So that'll look something like this. So the volume that we want will be from 0 to 2 of 2 to the x, that's quantity squared dx, minus the volume from 1 to 2 for the square root of x minus 1, quantity squared dx. Okay, so let's just sort of clean up this. We've got 2 to the 2x dx minus pi from 1 to 2 of x minus 1 dx. And we can't combine them because we've got different limits here. So pi. So the antiderivative of 2 to the 2x is going to be 2 to the 2x divided by 2 ln 2. And you can kind of find how you do that off of your formula sheet, because of the integral of ln of b to the x minus pi, and this one's a little bit easier, x squared minus x from 2 to 1. Alright, so now it's just expanding and collecting, and so let's go over here. Pi, not a nice pi. Let's start over. This is a problem with tablets. Pi. Okay, so we have 2 to the 2 times 2, so this will be 2 to the 4th over 2 ln 2 minus, and for the 0, this will be 2 to the 0, so minus 2 to the 0 over 2 ln 2. From that, we will subtract the red volume, and that's going to be 2 squared. Oh, wait, this is x squared over 2. So this will be 2 squared over 2. 2 squared over 2 minus 2. Let's just do this. Minus 1 over 2 minus 1. Okay, and okay, 1 squared there. Okay, so this is 16 and this is 1. So 16 minus 1 is 15 pi. Okay, pi is going to come in. And 2 ln 2, well, that's also the ln of 2 squared, so that's ln 4 minus pi. Okay, what do we have here? This is 4 divided by 2 is 2, minus 2 is 0, so this whole thing is just 0. Okay, we've got minus 1/2 plus 1, so that's going to be plus 1/2. And then we've got this minus here, so it's just going to be minus 1/2. So here, why don't we just clean this up? Go back. Okay, no. Okay, so that's 0. This is 1/2 minus 1, which is negative 1/2, minus negative 1/2 is plus 1/2. Then we've got minus 1/2 times pi, or minus pi over 2. Okay, so maybe that's it, or maybe we have a common denominator of 2 ln 4, right? Multiplying these. So the 15 pi needs a 2, so that'll be 30 pi. And the pi is going to need a ln 4, so minus pi ln 4. And ultimately, we can go 30 pi minus pi ln 4 over, and the 2 can come up here, so that could be a ln 16, and now it's cleanly done. And you can